Okay, question 7. So, four identical point charges are arranged as shown, arranged at the corners of the square as shown. So, what statement is true about the electric field strength E, and the electric potential at the center X? Okay, so you have 4 point charges arranged at the corners of the square, and then you want to know what is the electric field strength at this X, and also the V at this X. Okay, so now let's analyze the electric field first. Okay, now there's this your electric field strength, it follows, both of these follow the principle of superposition. That means you can just add them up. But the difference between these two things is this has direction. This is a vector, this is a scalar. Okay, vectors have direction. Okay, so now let's analyze it one by one. Let's look at the first point charge. What will be the force? Let's say I put a positive charge here. Okay, if let's say I put a positive charge here, what will be the force, direction of the force on this positive charge? It will be away, pointing away from this guy, so it will be here. Agree? Okay, so the force from Q1 will be in this direction. What about this guy? Okay, the force on this guy will be in this direction. Okay, the force from this guy, from this third charge, will be in this direction, and the force from this fourth charge will be in this direction. Notice these two forces cancel out. That means the force by this charge on this, your test charge, will be in this direction, will be cancelled out by the force from this third charge, okay, on the point charge. Okay, so these two cancel out, these two cancel out. Therefore, your electric field strength, even though all of them have the same magnitude, but because they have different direction, the electric field all will cancel out. So this will be 0. So A and B cannot be the answer, only C and D. Okay, you might think, that follows the same for V, but remember, V is a scalar. Scalars do not have direction, only numbers. Okay, it's only have a magnitude. Okay, so this is for E. Let me erase that. Okay, so now what about the potential at this point? So the potential caused by this charge will be, let's say, just some positive value. Okay, potential, let's just use PE, or electric potential energy. EPE is equals to V times Q, right? Okay, so they will just add up. Okay, at this point, that means this guy, let's say the potential from the first charge on this point will just be some positive value. Let's say let's just give it any value, plus 10. Okay, the potential from this guy also will be just some positive value, another plus 10. Okay, this guy also plus 10, this guy also plus 10. Okay, they add up. Okay, and all these four potentials just add up. Okay, they just add up, and they do not have direction, so they cannot cancel each other, they just add up. Okay, so therefore V will be non-zero unless this is a negative charge. Then you will have negative, let's say, you will have negative potential. Then only then this negative potential will cancel out the one by the positive charge. Okay, if this is a negative charge, it will contribute a negative potential, and therefore negative plus positive, then you will get 0. So if you have two positive charges and two negative charges, then it will be 0. But in this question, all four charges are positive charge, therefore four positive charges just add up, it will be positive, non-zero. Okay, so answer must be C.